Find the first four terms in this sequence given to us by a sub n. A sub n means the nth term equals a sub n minus 1, which means previous term times 3. My first term is 3, so the first four terms, well, I already have the first term. It's 3. The way I find the second term is I use this formula and I say the second term is going to be a sub 2 minus 1 times 3. A sub 2 minus 1 is the same as a sub 1. And a sub 1 is 3, so 3 times 3 is 9. Didn't do myself a good job giving myself space there. I regret it. Let me move to the left a little bit. So the third term is going to be a sub 3 minus 1 times 3. A sub 3 minus 1 is the second term. And the second term we found out was 9, so 9 times 3 is 27. So you kind of are figuring out the pattern, I hope. 3, 9, 27, I wonder what happens next. A sub 4 is the same as, that's the fourth term, a sub 4 minus 1, which is the same as the previous term, a sub 3, and a sub 3 is 27, and 27 times 3 is 81. So my four terms are going to be 3, 9, 27, 81. I am one of these ages. 81. Just kidding. I'm 73. Find the 10th term in this sequence. I'm going to need all the space I can get. Well, this is saying the nth term is going to equal a previous term plus the number term that you're dealing with. So we're not dealing with any specific pattern. It's not like you add 3 each time or multiply by a half each time. It's not simple like that. It's a little more complicated, so I'm going to write this all out, which requires a little bit of space. My first term, I already know, it's negative 8. It says it right there. My second term is going to be a sub n minus 1. So a sub 2 minus 1 plus 2, which is the same as the first term plus 2. So negative 8 plus 2 is negative 6. Okay, the third term is going to equal the previous term, because 2 minus 1 is 2, and then I'm going to add 3 to that. The previous term, a sub 2, was negative 6, so negative 6 plus 3 is negative 3. Okay, I think I see the pattern here. A sub 4 is going to be the previous term, so negative 3 plus 4 is 1. A sub 5 is the previous term, 1 plus 5 is 6. The sixth term is going to be the fifth term plus 6, which is 12. The seventh term is going to be the previous term plus 7, which is 19. The eighth term is going to be the previous term plus 8, which is 27. The ninth term is going to equal the previous term plus 9, which is 36. And the 10th term is going to be the previous term plus 10, which is 46. So once you kind of get the hang of it, you don't need to make everything look like we did for the second term. So we kind of whittled things down one step at a time, ended up with 46 in the end. That's my guy, and I'm sticking with 46. 46, my age in about 25 years. Just kidding. Much older than that. Not older than 46. I'm much older than 20. Like and subscribe. Determine if the sequence converges or diverges. If something converges, it's approaching a number. Like, for example, if I were to give you a pattern where I have, like, I don't know, 4, and then I divide by 2, and then I divide 2 again, and then I divide 2 again, and then I divide 2 again, you can see that this guy is getting smaller and smaller and smaller. And as I keep doing this, it's going to end up being like, that's 4, that's 2, that's 0.5, that's 0.25, that's point something else. What is that? 125, and then smaller and then smaller. Eventually, this is going to get so small, so close to 0, that that's something that converges. Something that diverges is it's either hitting infinity or it's going all over the place. So if I were to reverse it and have something like, I don't know, like 2, 4, 6, 8, that's going to keep going and get bigger and bigger and bigger and never really approach a number except for infinity. Or if I were to complicate it and make this negative, positive, that's not going towards a number either. That's diverging. So what I want to do is let me see if I can find the first couple terms, figure this out, and see what I can do. A sub first term is going to be -4 times -4 times 1 minus 1. All right, let me get rid of this mess over here because I'm going to need the space. Okay. -4 times -4, to the 0. That's going to become 1, and -4 times 1 is -4. Okay, so I start out with -4. I can handle this. The second term is going to be -4 times -4 to the 2 minus 1, so I'll just put 1 there. And so this is going to be -4 times -4, which is 16. So I went down from -4 and I jumped from -4 to 16. So it doesn't look really promising, but let's just do maybe 1 or 2 more, see what happens. So the third term is going to be -4 times -4 to the 3 minus 1, which is 2. So -4 times positive 16 is going to be -64. So there's a pattern, and that pattern is negative, positive, negative. The digit's getting larger, and we're going from positive to negative to positive to negative. This isn't going anywhere except for all over the place. This guy is diverging. Evaluate the series given to you by sigma, where it starts out at 1, goes to 5, and I have that polynomial. A series is when you take terms and add them up. Sigma is telling you sum. This is called summation notation. This tells you start out with 1, you plug in 1, then 2, then 3, then 4, then 5, end at 5, and add everything in between. So let's do that. Let's do 200 minus 1 squared, which is 1, plus 200 minus 2 squared, which is 4, plus 200 minus 3 squared, which is 9, plus 200 minus 4 squared, which is a fun game, 16, plus, last but not least, 200 minus 5 squared, which is 25. All right, let's simplify all these guys. We got 199, which is 100 more problems than Jay-Z had. We have 196. We have 191. We have 184. And we have 175. Oh, let me just add these up in my head. 945. So that's it. We evaluated the series and we ended up with that big number right there. Bam! Evaluate the series 1 over n, where we start out at 3 and we end at 9. So again, we have our sigma right there. This says plug in 3, and then plug in 4, and then plug in 5, then add up all of those and keep going until you hit 9. So we're going to have 1 over 3 plus 1 over 4 plus 1 over 5 plus 1 over 6 plus 1 over 7 plus 1 over 8 plus 1 over 9. Stop. Let me figure out what this is in my head. 3,349 over 2,520. Yeah, that's what it becomes. Let me just quick type it into a calculator and make sure I'm right. Yep, just did. Yeah, I'm right. Of course I'm right. I did it in my head. Determine if the sequence is arithmetic. If it is, find the 52nd term. Arithmetic means is, do I have a pattern where every time I add the same exact number to get from one number to the next? So to get from 34 to 28, I subtract 6. Do I subtract 6 here? Yup. Do I subtract 6 here again? Yup. So what I have is an arithmetic sequence where my first term is 34. My common difference is, since I subtract 6, is negative 6, and what I need to do is find out the 52nd term. Now, what we're going to do is write out the explicit formula for an arithmetic sequence. Now, the explicit formula for an arithmetic sequence is a sequence that involves a lot of cursing. Ha ha ha! I'm just kidding. No cursing. We keep this kid friendly here. Although, if you want a cursing version, I'll make a Patreon or something like that. My parents would be very disappointed. Anyway, that's my formula. So if I need to find the 52nd term, what I'm going to do is I'm going to replace n with 52. I'm going to replace a sub 1, which is 34. I know that from here. I'm going to add n minus 1 in the parentheses. N, once again, is 52. 52 minus 1 times d, which is negative 6. So a little bit of PEMDAS is 51 times negative 6. I'm going to not pretend like I can do all this in my head. I typed it out ahead of time. Negative 272. So this is me asking for the 52nd term. Don't confuse this with series. I'm not adding anything up. I'm just, if I were to keep this process going, or I subtract 6 like 40 some more times, the 52nd term is going to be negative 272. Okay? Arithmetic, not arithmetic. Arithmetic. Evaluate the arithmetic series. Now, series means you take all these numbers in a pattern and you add them all up. Now, there's a formula for that. The formula for an arithmetic series is the sum of the first n digits is going to equal n, so in this case 12, times the average of the first term and the last term. Okay, so writing out what we know, this means what am I doing? The 12th term. So the sum of the first 12 terms, where I have a first term of negative 22, so the opposite of the Taylor Swift special. My last term is, I don't know. Oh, that's a shame. So what I have to do is I have to go off to the side here. And I have to use the explicit formula for the arithmetic sequence, which is a sub n equals a sub 1 plus n minus 1 in parentheses times the common difference. I need to find the 12th term in this sequence or series. So negative 22 plus n minus 1 is going to be 12 minus 1 times the common differences. Thank goodness for that. Negative 3. Type all of that into your calculator, and you end up with negative 55. So I now know that the 12th term of this sequence is going to be negative 55. Looks sloppy, not the end of the world. So that ends up being negative 462. So if I have a series that starts out at negative 22, and then I subtract 3, negative 25, and then I subtract 3 again, negative 28, and I do that a total of 12 times where I have 12 numbers and then add them all up, that's the number that I get, negative 462. That is an arithmetic sequence in action. Evaluate the arithmetic series. So arithmetic series means I'm going to have a bunch of numbers and then add them all up. If I wanted to, there's two ways that I can handle this. I can plug in 2 and then plug in 3 and then plug in 4 all the way up through 10 and then add that up. But that is not what I'm going to do here. That's not what I'm going to do here. What I'm going to do is I'm going to say, all right, well, let's find my first term. My first term has me, be careful, plugging in 2. And by the way, this is not imaginary number I. This is just saying I'm starting out with variable I and is 2. So that has the potential of being confusing. Don't let it. And of course, the first term, you would think that I'd plug in 1, but actually I started 2 here. So my first term is going to be 0.8 times 2 minus 6.3, and my first term is going to end up being negative 4.7. Now, my last term is actually the 9th term, because if I start out at 2 and go all the way to 10, that's 9 terms. And so to find my last term, I'm going to do 0.8. I'm going to plug in 10 minus 6.3. So that's going to be 8 minus 6.3. I can handle that one in my head. There you go. Now I'm going to use the arithmetic sums formula, which says that the sum of the first n terms is going to equal the number of terms times the average of the first term and the last term. Bada bing. So the sum of these 9 terms is going to be 9 times the first term, which I found to be negative 4.7, plus the last term, which I found to be 1.7, all over 2. You run to your calculator, you type all that in, you get negative 13.5. So there's 2 ways I could have done it, and it wouldn't have been the end of the world if I started out with 2 and then made my way all the way up to 10 and then added them up. But I have a feeling this is the way they'd want us to do this if this was on a test and they asked you to show work. I think this is the way you would impress your teacher. I know since I am a teacher, I'm impressing myself so much right now by doing this. Determine if the sequence is geometric. If it is, find the 8th term. Geometric means, am I multiplying the same number from this guy to get to that guy, the same number to get to that guy, the same number to get to that guy? Well, in order to get from 0.75, multiply something and get to 3, I multiply 4. And then 3 times 4 is 12, and then 12 times 4 is 48. Is this geometric? Yes. Now, if it is, find the 8th term. Well, the explicit formula for a geometric sequence is a sub n equals the first term times the common ratio, which is, in this case, 4, to the n minus 1 power. So let's again list what I know. Okay, I know that my first term is 0.75. I know that my common ratio is 4, and n in this case is going to be 8. So a sub 8, the 8th term, is going to be 0.75 times my common ratio 4 to the, 8 minus 1 power. So, I guess showing one step is 0.75 times 4 to the 7th. I don't know what 4 to the 7th is. So 4 to the 7th is blah-de-blah-de-blah. You multiply that to 0.75 and you get 12,200 288. So if you were to keep this process going, if you were to keep multiplying this by 4 a couple more times, which wouldn't be the end of the world, you'd end up with 12,288. So there you go, geometric sequences. Evaluate the geometric series. So first off, it's geometric, which means you multiply a number every time to get to the next guy. It's a series, which means you add everything up, and I want 8 terms. So this is the equation for the sum of the first n terms in a geometric sequence. You take the first term, you multiply it to a fraction. In the numerator, it's 1 minus r to the n over 1 minus r in the denominator, close parentheses. I know my first term. It looks like I'm multiplying 4 every time, so my common ratio is 4. And it looks like I'm already have 8. So if you're like, oh, I need to find the 8th term, no, I don't. If it was an arithmetic series, yes, I would. But with geometric, I don't need to find the 8th term. So that makes life a little bit easier. So the sum of the first 8 terms in this geometric sequence or series is going to be the first term, which was 2, times 1 minus r, which is 4, to the 8th power over 1 minus 4. Just showing a little bit of work. That ended up being 1 minus 4 to the 8th is negative 6,500, or negative 65,535 over negative 3. And when you multiply all that together, you get 43,690. So if I were to keep multiplying this by 8, do it a couple more times, I would have 8 numbers. And when you add them all up, you get that number right there. That's how I evaluate a geometric series without doing too much work. Although the work here isn't the worst. I mean, if you had to double check your work and just go, okay, fine, times 4, times 4, times 4, times 4, plus, 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 it would be all right. But this wasn't so bad either. Evaluate the geometric series that starts out with 1, ends at 8. We have a sigma here, which means you add stuff up. Oh, this is going to be a mess. Now, what I could do is I could plug in 1 and plug in 2 and plug in 3 and do some math and add some stuff up. But that's not the way that we really should be doing it. What we should do is we should first things first find out, well, let's write out the geometric series formula. Okay? It's the first term, which I don't know yet, times 1 minus r, which I can figure out pretty easily, to the n, which is going to be 8 over 1 minus r. All right, so you are my n. My common ratio is always the guy inside the parentheses, so you're my r. Now, what I need to do is I need to find the first term. And the way I can find the first term is I just plug in 1 into that guy, which won't be so bad, and you'll see why. 32 times 1/2 to the 1 minus 1 is 1/2 to the 0th power. Anything to the 0th power is 1, so 32 times 1 is 32. There's my first term. So the sum of the first 8 terms in this geometric series is going to be 32 times 1 minus r, which is 1/2, gross, to the n. So let me put parentheses around that to make that look better. N was 8 over 1 minus 1/2. So let's show a little bit of work. 32 doesn't change yet. Let's make that bigger. 1/2 to the 8th power is an awful number. 1 minus that is going to be 255 over 256. Now that's going to be over 1 minus 1/2, which is 1/2. Now, in order to do a fraction over a fraction, you multiply the top and the bottom by its reciprocal so the bottom, the numerator, can completely go away. So now what I have is 32 times this fraction times 2, which ends up changing it to 255 over 128. 32 times 255 over 128 is 255 over 4. So if I were to take these, plug in 1, plug in 2, plug in 3, plug in 4, all the way up to 8, then add them up, I get that guy right there. All right, so that's geometric series. Pretty exciting stuff.